didn't see you there. Welcome to 7th grade. I'm Mr. Framke, and this is your first video homework where we talk about what we're going to talk about tomorrow. So, our first unit is called Accentuate the Negative. We all love negative thinking, don't we? But in Accentuate the Negative, we're going to take a look at integers. That is, positive and negative numbers, including fractions. And we're going to look at how to manipulate them using the standard operations, adding, subtracting, dividing, and multiplying. I understand that many of you already know how to do this. That's great. It'll be a fairly easy first 3 weeks for you. However, for us to continue in 7th grade math, we need to make sure everybody can add, subtract, divide, and multiply with integers, including fractions, before we move forward. Because if you don't, it's going to be a rough year. Now, normally my policy in 7th grade is use a calculator for everything. The only exception is no calculators for this unit. So in Accentuate the Negative, I do expect you to do everything with a pen, your head, and a piece of paper. No calculators. The second unit and all other units after that, calculators, free reign, have at it, have a great time. So, we're extending the number line, and I realize there are lots of elementary teachers out there who told you that the numbers start at 0 and go on from there forever. Well, that's only half the story. Obviously, we have negative numbers. How do we talk about debt? How do we talk about temperatures below 0? Well, we have negative numbers, and you'll get to be very comfortable with negative numbers soon. If you're not already, no big deal. So today we're talking about extending that number line, and we're talking about rational numbers. Now this is an important idea, a rational number. A rational number is any number that can be expressed as a fraction with whole number values in the numerator and the denominator. For example, 2/3, it's kind of a tricky one, but 2/3 is a rational number, because this rational number can be expressed as a fraction with a whole number in the numerator and a whole number in the denominator. Let's try another one. How about just plain old 2? Well, 2 is also a rational number because it can be expressed as a fraction with whole number parts. So 2/1 is a fraction, which is equal to 2, where this, there we go, that's a better looking one, where 2 is a whole number, 1 is a whole number, therefore 2 is a rational number. Now, there's a misconception that a rational number has to have a decimal that terminates. That's not true. Now, we know that 1/2 is a rational number because 1 and 2 are both whole numbers, and 1/2 is equal to 0.5. It terminates, it ends. We know that 1/4 is equal to 0.25. Okay. Now, the big question becomes 1/3. Well, 1/3 is equal to 0.333 repeating. But remember, the question is, a rational number is a number that has a whole number in the numerator, a whole number in the denominator. Well, we have a whole number and a whole number, and the decimal goes on forever. That's okay, it's still rational, but we have a repeating decimal. So if you have any fraction that can be expressed as a terminating decimal, both of these are terminating, they end, or a fraction that can be expressed as a decimal that is repeating at any point, we're talking about a rational number. An irrational number, kind of like your parents, that is going to be a number that can't be expressed as a terminating decimal or a repeating decimal or a fraction as a whole number. Now, can you think about an irrational number that you know about? I can think of one that I'm sure you do. Pi is an irrational number. Pi is an irrational number because the digits of pi go on forever and it never repeats. My personal favorite, we'll do a lesson on my personal favorite number. This is an important one for you to remember, so write this one down. My favorite number is phi. Phi can be approximated, but it's not exact. 1.61, and it goes on forever. And we'll talk about the amazing properties of phi at some point when I feel like it. So anyways, an irrational number, another irrational number, the square root of 2. So if I do pull up a calculator, I know I just said never do that, and I do the square root of 2, I get a decimal that it will go on forever, and it never repeats. So that's what it means by irrational number, and that's something you definitely need to remember. Okay, so when we're talking about rational numbers, every rational number, with the exception of 0, has an opposite. So an opposite is a number that is equidistant from your original number on the number line. For example, 2 has an opposite of -2. -5 has an opposite, which is equidistant from 0, at 5. 0, what's the opposite of 0? 0. All right, so what we're going to be doing tomorrow is we're going to be talking about values on the number line. We're going to be talking about rational numbers, and we are going to be looking at we're going to be talking about temperatures mostly, and how far away from a specific temperature other numbers are. We are leading into writing algorithms for adding and subtracting with negative numbers. So that's where this is going. All right, remember, you're supposed to be taking notes on this, right? If you didn't, don't worry. You can rewind the video and take notes as I go through it again, because this is never going to go away. It's on YouTube forever. All right, I'll see you tomorrow. Have a great evening, and I hope your homework wasn't too arduous tonight.